Welcome Algebra 3. We're in Lesson 57. So today we're going to talk about sinusoids again. We're going to add a little bit more information to what we already know. So let's just review what we already know first. So far we've learned that we can write a sinusoid function as y is equal to the axis plus the amplitude times the sine of theta, which just means that we have the midline of our sinusoid with how far up or down the sinusoid goes. And when it says sine, it crosses y at the origin. And the same thing for the cosine, except that when it says cosine, the y crosses at the amplitude. And if it's a positive amplitude, then cosine crosses at the positive amplitude, and if it's a negative, then it crosses first at the negative amplitude. And for the sine, if it's a positive amplitude, then it just means that when it leaves the origin, it goes straight up. If it's a negative amplitude, when it leaves the origin, it goes down. So let's look at a few examples of that. And I've written us out some sinusoids here. Let me pull this up to get that to, it's a little jumpy today. It's taking its own sweet time. All right, so let's look at the first one that I have. And this is the very first ones we started with. Oh goodness, that is kind of stretched out. Let me zoom out so we can see that a little bit better. It's taking its own sweet time. All right, so now we can see that a little bit better. So this is a 4 sine. That means amplitude sine. So that means it has a height and a depth of 4. And because it's a positive sine crosses at the origin, and it goes up because it's positive, and it goes up to the 4. And then it goes down to the 4. Now, if we had had a negative sine, then you would see, here's the red line, it crosses the origin, and then it goes down first, and then it goes back up. But the midline is the x-axis. So that is our sine. So let's look at our cosine. Cosine is when the amplitude is what crosses the y-axis. Now, if it's a positive cosine amplitude, then it goes up and crosses at that positive number first. If it's a negative, then it crosses the y-axis at the negative amplitude, which here it's -4, and then it continues on its back and forth motion. So the blue is the positive, and the orange is the negative. And so we learned that first. We learned how to see what the amplitude was, what the midline or the axis was, and how to read those. So then we went from there to translating or moving the sinusoid up or down along the y-axis. So here is an example of that. Here we have, let me see if I can move this down a little bit. There we go. Here we have y is equal to 2 plus 4 sine. So that just means that this first number here, that is going to be our axis. So you see our axis is 2, and it has a positive amplitude of 4. So it crosses at the origin, which is the 2 on the y-axis, and it goes up 4 spaces, and then it comes back, crosses the axis, and it comes down 4 spaces. So it goes between 4 and -2 with a midline of +2. So that is the illustration of the translation up or down the y-axis. And we can do that with a negative also. We come down here, we see that we can cross the y-axis at a -2. It's the same line. I'm going to put both of them up here together. They're just in different locations. And that original, where it crosses at the 0, that's the green line. So you can see where it crosses the 0. We don't have that number in front because that number is 0. It's 0 plus 4 sine, and we know that the 0 just goes away. So that's why we wrote that originally like that. But then let's take that one away. But then when we move it up or down, we add how far we move it up or down based on positive or negative in front of that sinusoid. Same thing for cosine. Here's that original cosine. When we translate that cosine up 2, it looks like that. So now that highest amplitude is above, because the midline, if I erase the blue line, you can see the midline is positive 2. So it goes from 6 to 2, and then from 2 to negative 2. 4 above and 4 below. And a negative 2 with that same amplitude is going to have a negative 2 for its midline, and it's going to go up 4, and it's going to go down 4. It's just that it's in a different location. It's the same line, just in a different location. That's because we have that 4 amplitude. So what if we want to move it from left to right instead of up or down? That's when we go to the degree of measure, the x or the theta itself, and then we start adding some degrees left or right. And actually what we're going to be doing is subtracting degrees left or right. So let me illustrate that for you. So when we have a sinusoid, so here's our function, the way we would write. The one that we've been using is 2 plus 4 sine. When we're looking at the sine, we're looking at where it crosses the midline. Where does it cross this 2 at? That's what we're looking for. And that's going to be our x or our theta. That's what the x-axis is called, depending on how it's labeled. We'll just call it theta for now. If that shifts from left to right, we mark that out in degrees of measure. So what if we shift it so that the x, or not the x, but the midline is crossed at negative 60 degrees? Well, a negative and a negative, we're moving it back, that's going to be a positive. So we would actually write that as theta plus 60 degrees. So let's go see what that looks like. So here we have what that looks like. So we have this isn't shifted on the y-axis, it's centered on the original x-axis, so we don't have a number in front. All we have is a shift where instead of crossing at the origin, the sine is crossing back here 60 degrees behind the origin. That's where our midline is crossing. And we always take the closest measure whenever that occurs. So our closest measure, this is shorter to the origin than this one is. So we always use the closest measure, and in this case, it's negative 60 degrees. Right in the middle would be negative 45. Let me show you what that one looks like. This is exactly in the middle. This is negative 45 degrees right there. Right, so this would be negative 90. This would be negative 45. So you see how the midline crosses right in the middle? So it's shifted. So we would write that as x minus negative 45, which would be x plus 45 degrees, because a negative and a negative make a positive. And so that's how a sine would work. So when we write that one with the amplitude of 2, you would go up to 2, and it would cross at the negative 60 behind or to the left of, on the negative side of the y-axis. All right, so what about if it is a cosine? Well, a cosine is all about, let me write out the cosine here. Cosine is looking for the amplitude. It's asking, cosine crosses y at the amplitude. So we're looking for where would this cosine cross at the amplitude. Well, if it is a negative, let's say negative 45 is where the sine hits. Let me go back to here. If, for instance, this positive 45 right here is where the axis is, or where the midline is, negative minus 45 degrees is plus 45 degrees, then the amplitude for a cosine, that's where we're looking for our cosine statement. And if you look, 45 degrees on this side, remember these are 90 degrees apart. So 45 degrees on this side is going to be 45 degrees on this side. So our amplitude is going to hit at a positive 45 degrees. And x minus a positive 45 degrees is going to be negative 45. So where our amplitude hits, it's going to be the opposite. It's going to be 90 minus whatever this is. So if you look, it's exactly the same line. We can say cosine of x minus 45, because we're looking at the amplitude, is the same thing as sine x plus 45, because we're looking at where the midline crosses, or where it crosses the axis. So let's look at that original one, where we have 2 times the amplitude of 2 sine of x plus 60 degrees, which means it's crossing at the negative 60. That same exact line can be written as a cosine because 60 from 90 leaves 30. So our amplitude is hitting at the 30-degree mark on the positive side of the x-axis. And we know x minus a positive 30 is going to be x minus 30. So where the amplitude hits is going to be 2 cosine x minus 30. And if I tap that sinusoid, you see it lands right on top. It is the exact same line. And that's how we would shift from left to right, is we just subtract the degree of measure that it shifts from our original theta or our x. And if it's a sine function, we're looking for where the midline shifts from the origin. If it is a cosine function, we're looking for where the amplitude shifts from the origin. And so that is what we're looking for. And we always look for the first occurrence or the shortest occurrence of that. So let's look at one where we have a translation up 4 spaces. Our midline is at 4. And then we have a backward shift to negative 60 degrees of our crossing the midline. And this is going to be the sine function of 4 with an amplitude of 2 back 60 degrees for the crossing of the midline of the axis. Now, we can rewrite that as a cosine function by saying we have an amplitude of 4, a midline of 4 with an amplitude of 2, but the amplitude, or the cosine, is going to be at x minus 30 degrees. So when I put that blue line on top, you see it's exactly the same line. The sine and the cosine just mean 2 different things. It just means sine is where does the midline get crossed, where does the axis get crossed, are the same thing. And cosine means where does the amplitude hit. What is that? And so that is what we are looking for whenever we talk about translation left or right. It is the degree of measure from one side to the other. So if we're going to have the same exact line where we shifted the crossing of the midline back 60 degrees, on the other side, because they have to equal 90 degrees, it's going to be at the positive 30-degree mark. So theta minus 30 degrees, it just means that our amplitude is shifted back 30 degrees, which makes perfect sense when you realize that the crossing of the midline is shifted back 60 degrees. So it's an offsetting for a total of 90 degrees between the sine and the cosine. So here we have a translation up the y-axis, because this is positive, with an amplitude of 4. So this is our midline, and it goes up above midline 4 and below the midline 4. And we're looking for where it crosses the midline, and that's at negative 60 degrees. And that's all that means. All this one means is that we have a midline of 2 with an amplitude above and below of 4, and the amplitude is going to cross or touch at the positive 30-degree mark. That's all that means.